This is actually a classic example because it's because it's really long. The next reason is that it has really like a lot of technical know-how in order to implement this type of algorithm, insertion in the middle of a linked list. But before we go into it, let me tell you something. There's different ways of implementing insert in the middle. One way is by inserting by specifying the index. Okay, so look, this is the first one, this is the second, this is the third, basically index of 0, 1 and 2. Let's just code all the edge cases that can exist. So think about it. One edge case would be that our linked list is empty. Okay, so if that's the case, we can say if head is equal to null. All right, then we don't want to return in that case. What we want to do is we want to insert at head, but I'm not going to say insert at head. I'm not going to write the code for it. I'm just going to call the function insert at head, which I already created previously on top. Okay, and after that I'm just going to return. So if I were to just go back, you can see this is insert at head, so it's going to call that function, and simply it's going to see that head is equal to null and it's going to insert a node there. Simple as that. All right, no need to stress much about it. Okay, so that's what it is. Head is equal to null. Now there's another edge case. Okay, because we're working with indexes, by the way, we're working with indexes, I want to insert an index called index. Okay, I'm going to say index and D for the data that I'm inserting, and by the way, this has to go into there, I forgot. Okay, now there's another way, another edge case. That's that assume our user enters a value that is smaller than 0, for example -10. Okay, so in that case that's an invalid value, but if he enters a value that is 0 or less than 0 of the index, then I want it to insert at the head right over here. So if I go back over here, I want to insert at head when the head is null, or if the index is less than or equal to 0. That's what it is. Okay, that's just when you want to insert at head. Next edge case would be if the value exceeds the length of the linked list. So now this linked list's length is 3 because it's 1, 2, 3 nodes inside of here. So there has to be a mechanism or a function where I calculate the length of the linked list, and if the user enters the length greater than 2, for example, basically greater than 3, then I want it to insert at tail. But first let's implement a mechanism to count the number of nodes inside of the linked list. And of course I have created that previously. I called that function countlen. If you don't know, then you can just watch one of my previous videos. It's a classic question. So I'm gonna say if countlen, okay, which is the function that is counting the number of elements inside of my linked list, if that is less than, or actually no, if it's greater than or even equal to index, and by the way, because this is an index, you know, index is 1 unit less, so I'm going to say countlen -1. Okay, if basically if the length of our linked list is 3, okay, because like in this case this is 1, 2, 3, so if we run countlen on this linked list, it's going to give us 3, but our index ends at 2, so that's why I'm doing -1. So now it's going to be 2 is the max. So if it's greater than 2 or even equal to 2, then what I want to do is I just want to do insert at tail. I want to call that function, and I'm going to put my data in there. Okay, and I'm going to return. Perfect, fine. Then by the way, this is what I've coded before if you saw my previous videos. Now there's a set of steps. First step would be to insert or to create a node. That's going to be step number 1. Create a node and our data is going to go inside there. Okay, next step would be step number 2. You're gonna create a temporary pointer. You're gonna point it to head, so we're looking for the index of 1. So once our t has reached this node right over here, which is index of 1, okay, t1 has reached here, just break it up into step number 2 for now. Step number 3 is going to be that you break the link between the previous node and you create a link between this node here. Let's put it here, sorry, excuse my writing, okay, and then this is gonna t's next node is going to point to t1. Okay, so t1 is going to be over here and our previous node is going to be this one. So this is 3, step number 3. So there's a number of steps involved here, and in order to, like, create a link between the previous node and our new node, you want to also give this a temporary name, which is going to be t2 or t3 or anything you want to do. So step number 1 was to create a node, right? Node t1. I'm going to call it t1. Actually no, t. Let's call it t. Okay, and I'm going to say it's equal to new node, and I'm going to put data inside of it. Then the next thing I want to do is I want to create a node t1 and point it to our head. Okay, this is step 2, and I'm going to increment it. I'm going to keep making it hop around, and actually, you know what, let's just use a for loop instead. For int I equals 0, I is not equal to index I plus plus. Okay, we're using a for loop because we want to loop it a known number of times. We know the number of times we want to loop it. We want to loop it index number of times. Okay, so we're gonna keep on saying t is equal to t dot next. Okay, that's how we do it. And after that, what you want to do, okay, that's just going to be step number 2, isn't it? Looping, hopping around. Actually, let's just make it stop index -1 times, because remember, if we don't do -1, we're going to stop here, but we want to stop here, alright, right over here, and then we're going to create t3, and after creating t3 we're going to increment t1 further, so t -1 times, and I'm going to create another node. I'm going to call it t3. I'm going to make it equal to, sorry, this should have been t1. I'm going to make it equal to t1, and after that, after I've made it equal to t1, I'm going to say t1 is equal to t1 dot next. Done. And once I'm done doing that, that's step number 2 completed. Step number 3 is to create the links. Okay, so t3 is equal to, actually no, t3 dot next, and remember t3 is what? T3 is right over here. Okay, so its next is going to point to our new node, which is t. Alright, and then t's next is going to be equal to t1, which is this one right over here. And once I'm done with that, it seems like our insert in middle code is complete. Mistake. if our index is greater than or equal to count len, and it is count len minus 1 because it's index.